So here's what we have. We're looking at pointers into calling a pointer into a function. I made a new struct called myPoint. It has an X position, a Y position. It is modifying the X value, but we did something weird. Instead of going into the individual element in my structure and putting an ampersand in front of it to get the pointer to that value, instead I just said, yeah, I already have a pointer. It's one of these myPoint pointers. I'm going to put that in there instead. And we get this infinite loop, essentially. I cannot get out of this. Why? Oh, wait. Why do you think I can't get out of this thing? I should be changing the Y pause value, right? What's happening? Why does it still think Y pause is negative? So I said, I'll wait. And by the way, you can guess randomly. I'm okay with that. Why is
it because the while loop is like you can only enter it if it is negative?
I only entered it if it is negative. It is, I made Y pause negative. So I went into the while loop. But normally when I get new input, normally I wanted to change the Y value, Y pause value. I'm changing something for sure, but Y pause stays negative. So I keep on going around that loop. Why don't I change the Y pause? Why isn't the Y pause changing? Or better yet, I am changing some value in this myPoint structure. What value am I changing?
Are you just changing like the pointer, but not the actual variables in the struct?
Oh, I almost guarantee you I'm changing a variable in the struct. Because remember, the scanf takes a pointer to something so you can modify it. It thinks it's an integer pointer.
Oh, you need like the and sign to the p underscore? I have no idea.
So let's take a break and let's do this. If we don't know what's going to happen, let's find out. So I'm going to printf my whole thing. So the point is now. Let's see what happens here. All right. So P to change X pause. That's one of my values. P to change Y pause. All right. So I'm just going to print off what the X and Y value are in my struct. With me so far, hopefully. All right. Compile away. Give me some kind of warning, but I'm allowed to mismatch. Whoa, what the heck? It's saying it's some kind of, I'm assuming it's some kind of, it's expecting an integer and it's not giving me, I'm not giving it an integer. So, all right. So let's make it 10, -2. Okay. What are my values here? I changed it from, originally the X value was 10. Y value is -2. I changed what I hope to be changing my Y value to 20. And instead, my X value is 20. Why? And so if I keep on doing this, by the way, let's say 30, the X value is now 30. The Y value didn't change. So this is actually the worst of all worlds. It blowing up in your face is actually easier to deal with than this crap. Why is the X value changing? Or better yet, what is this? Pointer. This is saying it's supposed to be a int pointer that I need to give. If I'm Because the first value of the pointer hits in the struct. Yep. So essentially, I point to the struct, the very first integer of that struct. It's just a chunk of data. The very first integer's worth of stuff in that struct is the X value. I can change it again if you really want to be crazy. Let's be crazy. I love being crazy. Here we go. Shouldn't make any difference. Yes, I do want to stop debugging. Okay, that should not make any difference whatsoever. I just moved my X and Y positions, flipped them around. Same struct, same storing the exact same stuff. Let's see what happens. Their value for X. Oh, sorry for all the beeping and blinking. This is what happens when you synchronize your Google Drive with this. All right, let's do -2, like I did before. Don't be a dumbass. Okay, let's make 20. And I'm out. Why? Because the very first variable in the struct, the first integer's worth of data happens to just accidentally happens to be ypos, the thing I needed to modify. It is purely accidental. That is not brilliance on my part. That is not good coding. That is being a dumbass. That is horrible, right? I should not be relying on the order in which the variables are placed and hoping to gosh no one moves that around, right? That it's like I don't know if you've ever seen like those egg parachute tests where you drop an egg off of a building and it doesn't smash. You can get lucky. The egg may not break. That doesn't mean you're smart, right? If you don't have the proper engineering for that egg drop and it doesn't break, that's not like, oh, look how brilliant I am. I threw the egg without any protection whatsoever and it didn't break. No, you got lucky. It landed on the right place or something like that. Or maybe you had a little bit of cardboard on it and it didn't break because you got lucky. Luck is not the same as planning. What I wanted here, I needed to have a pointer to the integer. So let's put a pointer to the integer. Okay, line 218. All right. What happens to the pointer in the scanf if you change it to, oh yeah, let's do that. This, I'm going to leave that printf in there because it might blow up in our face. It may not. Weird things can happen. Essentially, I'm going to leave off that ampersand. Great idea. This is the kind of thing that this is how you learn how pointers work, unfortunately. Okay, the 10. Let's do -2. All right, don't be a dumbass. 20. Boom. Why? Access violation. Why is it an access violation? What location are we trying to modify? It is an address. It's expecting an address in space. The address in space that you told it was what? Position -2 in your memory. Where is that? It doesn't exist in your memory. Notice it does an assertion, by the way. This is an assertion failure, like we are doing those assert statements everywhere else. Other programmers are using asserts in case you didn't know what, but this is an access violation. It's trying to go to a position that does not exist. It is trying to go to this position right here, actually. What is that position? Why is that? That's a huge number. Oh, we can move the struct back. Oh yeah, we can move the variable back. It won't make any difference at all in this code right now. But this is a huge number. So this is something kind of useful for you, everyone here. What? Why is it such a huge number? I'll wait on that one too. Well, and in the meantime, I'm going to move this back. That was a solid plan. Keep on moving stuff around. All right. So why is this huge number? Okay. It's massive. Right? If I convert that to binary, it is a slew of ones except for 1 0 at the end. That's what that is. It's all ones, the largest possible number, except for 1 off. So it's the largest possible number, largest possible address I could possibly give you, except there's a 0 at the end instead of a 1. Why? You'll have to go back way back earlier in the term, which fair game, by the way, on an exam. Where have we seen things like that? Huge, big, huge numbers. And keeping in mind, this is what I entered in here into the Y value. I'm sure somebody has it or figures it out. Would you like me to blow it up again with a different number? That's doable. Why is it FFFFFFFFE? And I'm going to ask someone to give me an answer before I cancel this whole thing. I don't care. I'm more than happy for you to be wrong. I don't want passive sitting back, hoping to God people figure things out. You do not learn by osmosis. You do not learn by passively sitting there. You learn by thinking things through. Sorry, I'm getting a little after a while. I need answers. Throw me something. Throw me a bone.
Does it have something to do with the Y value being negative, or
Yep, it absolutely does. Great.
is
Thank you.
is it
Somebody
because
else.
you're looking for an integer and not an unsigned integer, or
And what's the Y value as an unsigned integer?
it would allow it to take negatives?
Oh, so let me put it a different way. What's -2 in binary?
Oh no.
No, don't have to. It's easier than you might think, but I'm not gonna. And you can probably read your screen to be able to read it out.
So I know it had to start with like a 1 at the start of the code to make it negative.
There you go, Jeanette. Jeanette got it.
Oh, thank God, Jeanette, you saved me.
It's fine. It's okay. There's 6 of you. I've embarrassed myself in much larger cuts, and you didn't embarrass yourself at all. You did a great job. Uh, there's no shame in trying things out. This is what this is for. It's a negative value. So what's 2's complement? I don't have a sign bit at the front. Let's be very clear. 2's complement can show up on the exam. I didn't test it on the last exam. I sort of need to test some of it. Not hardcore, but I need to test some. What does 2's complement do? It is this flip the bits, add 1 thing, right? It's our way of hacking the system to allow us to have negative numbers when I only have 0s and 1s. So I take, this is my number system. I can store 0 to 255. I take the 1/2 of those numbers and just say, oh yeah, those are our negatives. So when I get above 127, 128 in binary suddenly becomes -128. And then it becomes -127, -126, -125, all the way up to -1, which is FFFFFFFFFFF. It's all ones. -1 is the largest number of bits. It's all ones in the number. If you want to try it out, take a number like 3, flip all your bits. You have to know how many bits you have. Flip all your bits, add 1. That is -3 in binary. So let me do that in a second, but let's hit Jeanette's thing because it's absolutely right. And it's the right answer here. It's all ones except a 0 at the end. Well, that's what -2 is. -1 is all ones. -2 is all ones except a 0 at the end. So if that's -2 in hexadecimal, it would be FFFFFFFFFFFFE, or whatever, however many Fs there are. And it thinks that's an address in space. The number -2, the address of -2 It doesn't exist. That's why we're getting an access violation. Is trying to put it into some place that does not even exist in memory. And that's why it's blowing up. That's what happens here. Is if I don't pass it an address, it thinks it's an address. The worst thing you can have is it coercing your data or pretending your data is right rather than yelling at you. Because you get weird things like this exception thrown, not compiler error. Compiler error sounds horrible for you guys, but it's far better than this garbage. Because a compiler error would you be like, oh, I need to put an ampersand in front of it, not this thing will blow up, 4 hours later when I finally test my code, because I know everyone does. You write your code and then you test it when you shouldn't, but right, you write all this code, then you test it, and you get this weird exploding error at some random place because you didn't know it had to be a pointer. It has to be a pointer. So if let's do it one more time. Let's put a -1 in there. We'll see it as FFFFFFFFFFFFF. And that will be what we would see. That's -1. So let's put -1 in here and let's see what we get. In case you don't believe me. So 10, -1. Don't be a dumbass. Okay. 20, but doesn't matter. Boom. So, and my position is FFFFFFFFFFFF. -1. You're passing a -1. It's saying, oh, that location in space, it's this massively huge number as a result. And that's why we need to learn two's complement, because I've hit that damn error more times than I can count. Not this many times, but a large number of times. It just comes up in weird, horrible ways, and you want to just pull your hair out. That's why I'm moving back. It just gets you. So that's what happens if I don't make it a pointer. Let's make it a pointer. And thank you guys for actually answering. Everyone else, come on. All right, so let's do our numbers here. Our Y value is going to be -2 again. Hey, don't be a dumbass. Okay, let's make it 20. Oh, Google. And it works. All right. That's why we have to deal with pointers. That's why there are weird things with pointers. That's why this thing is expecting, the scanf is expecting a pointer to a variable, to an integer. And if I don't give it a pointer to an integer, bad things will happen. This is a integer. I have a pointer. I dereference the pointer. So go into the address, get the value for ypos. Then I say, no, 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 I need the address of that position. And now I got the address to this variable. That's a pointer that I wanted to modify. Okay, let's do the same thing, slightly different way. Oh, actually, let's do it this way. We'll do it the stupid way. Just because I like doing things stupidly. Okay. Dot. Let's call it my point two. Yeah, point two. Okay. The variable is called server. All right. And I'm going to need to modify some values here. So instead of passing in a pointer, I'm passing in the actual values. I'm passing in I'm not actually passing in the variable, I'm passing in the values. That's what we do when we pass into a function. We don't pass variables, we pass values, or the location where a variable is, but we never actually pass the move around variables. That's actually what a pass by reference is, but we're not doing that really in the course. All right, and let me see, is there anything else? No. Get point 2. And go. Let's do the exact same thing as I did before. Initialize variable used. Okay, let's make this, because I know this is giving me a problem because it's in debug mode. It's normally more than happy to let me have God. PT dot next pause is equal to 0. PT dot y pause is equal to 0. All right. Let's try this. Once more, this is using the different version of it. I'm passing the actual point, my point, file2 change. I'm modifying the value of this thing, and then we're going to print off what we get. Okay. So let's use our normal values. So 10, 20. All right. And the point is 0, 0. What does this do? This will make a new variable called toChange. It will set the new variable to be equal to the thing calling it. So the thing calling it here is PT. It will say, okay, toChange, your X value is 0, your Y value is 0. It is not the same variable. They're stored in different locations even. The location where this is stored is a different location than the location of this variable here. We can actually print those out if you wanted to. The actual location where the variable is located is different. I make 2 different integers, one called toChange, the other one called PT. They are distinct, they are different. They have the same values, they're equivalent to each other, but they're located in 2 different places. And then I modify toChange. So when I call this function, I make a new variable called toChange, set the values to 0 and 0. I modify toChange, the struct toChange a bunch of times. And then I throw away toChange because I'm done my function. Bob's your uncle, good enough, and leave. And get point 2, nothing happens. PT is distinctly different. You didn't modify it. So I make a Xerox copy, essentially. So I have a page in my textbook. I Xerox a page in my textbook. I make my notes on the Xerox copy of my textbook, the Xerox page of my textbook. I make a bunch of notes on that. Crumple up that note, throw it away. My textbook has not been modified at all. I modified the Xerox copy. I did not modify the original. The other one is, lend me your textbooks, please. And so I say, hey, Andrew, can you lend me your textbook? And he goes, sure, because he thinks I'm a responsible adult, which I am not. He lends me the textbook. I go markering it up with all sorts of notes and crap like that, give it back to him. That's this one here. You lend me the textbook. I'm able to get the textbook from you by you say where it's located. It's over on the book. It's over there. So you walk over, I grab the textbook, I put markers and highlights and all this crap on it, put it back, and now he has a ruined textbook. Versus this thing is make a copy of the textbook, pass it to me, I mark it up. Who the hell cares? I'm using a copy of it. That's the difference between those two. What I could do here is this. This would be the workaround for this. Return toChange. I modified toChange. I return it back again later. And the workaround would be the following. Here's what I would do. That would do the same thing as my original one did. I get some values, I change some values, I pass the values back over. I now catch the values in this variable again. I make them equal to each other again. So I pass you the notes and then you go, okay, I'm going to transcribe the notes into my textbook afterwards. Very, very different. Okay, and let me point out, so let's run it this way. And then in a second, we're going to see why, there's always potential issues with all these things. 10, 20. All right, values 10 and 20. That's what we expected, right? This thing, PT, gets reset based on what this thing returns back a point, and it changes the values in PT. So I'm throwing and catching values back and forth. And won't cause an error. It's going to happily do it. And 20, and I'm right back to where I was before. Because if I don't catch what this thing is returning, that's why scanf works the way it does. If I don't catch what this thing is returning, and if I wanted to, let's say, I'm making an array, or I need to modify an array, and I need to say how many elements I entered into the array. I have two different return things. I have the number of elements I've added to my array and the array itself. I can't return two things at once without using a structure or some other workaround. And that's another reason why we use pointers. So I can return multiple pieces of data in one function. Nope, unless I tell you to do it one way or the other. It's wrong if I say, yes, you need to take a pointer and it's a void. If I say, here's this function, it's a void function, and it takes in a pointer to my point, then you sort of have to do it this way. If I say it takes in a point on my point and it returns a my point, then it has to be done this way. There's only one way of doing it. Both would be fine. If you can get away with this, I normally go with this if I can, and this if I really can't. Right. So let me think of another example. If I wanted to modify 2 points at once, or if I wanted to fill in an array of values, I pass in the array, I fill in the array. I need to know how many elements I have. So something like, I'm just going to write the top line for it. Let's do an unsigned int. So I'm going to get a whole bunch of scanf statements from the user. I'm going to pass in this array that's already made for me. I'm going to have a maximum size of that array. So let's say it's 20. And I keep on asking the user to type in a number to put in the array, or put in -1 when you want to stop, or don't put in anything if you want to stop. Something like that, or put in 0 when you want to stop. And so at some point in time, they put in 0. They would put in, they would stop doing this before they got to the end, or we'd force it to stop at the end. Now, in this case, I want to fill in the array, the original array. It's a pointer to the array, so I'm allowed to do that. And at the end of the day, I want to say how many items I've actually entered into the array. That make sense? All right, Sarah, let's see what you had to say. Would store a string and an array. No, in an array. Okay, in an array. And how would you print it afterwards? Oh, so an array of strings, perhaps? Is that what you want? Let's do that. So let's just comment that out, actually. Get names. I'm going to have an array of strings, and I'm going to put in a whole bunch of names. Add on returning how many items are entered. So for this fill array, I'm returning the number of items the person entered in, not the maximum size, but how many things they've entered in. And I'm going to do that as an example right now, actually. So I'm going to get names for the user. I have a character, an array of arrays, so an array of character arrays. So it's actually going to be an array of pointers, of character array pointer, an array of character pointers. So unsigned int max num names. Okay. And f enter name. Enter. Let's find out if this thing is going to work. Hopefully it's going to work. Okay. So I'm going to make a while loop, and I'm going to figure out if I've maybe a do while loop. Let's do that. Just because, why not? While I need to get the current name. Okay, we're going to make a new variable each time. A new, can I do that? The current name that I'm looking at. Let's say it's, so here's our, I'm going to have a current name each time. So current name, I'm going to make a brand new array to store the name. So ignoring the big old array of arrays, I'm just going to make an array that stores a name. So I'm going to call malloc. Malloc always takes in the size of the thing I'm storing. It's a char. And we said maximum of 20 characters. So I'm going to put in a 20 here. Notice I'm not using a static array. Why? Because if I make a static array here, it gets given back right at this line, right at the end of that line there. Actually, it might actually be given back right at the end of this while loop. Either case, it doesn't stay around. It's not mine to use and manipulate and pass around. So I need to call malloc, even if it's using a constant. Okay. And my malloc, every single time, it just gives me a void pointer, just some kind of pointer to somewhere. I want to say, no, 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 no. This thing is a character array. So I'm going to make an array with 20 characters. I'm asking for 20 bytes of data. And then I'm saying this is an array of characters, 20 of them to be exact. Okay, named current name. Let's get the actual name here. So scanf. Notice this is a pointer to the front of that memory. It's a pointer already. So scanf, I need a pointer to where that memory is going. Oh, wait, and let's do _s. Always forget the parameter order of this thing. I do believe it's the number of elements after the fact. So let's try that at least. And I do believe it's going to be size 20 is the maximum. But we're going to find out the hard way. Find out. All right. How do I know when I'm done? I know when I'm done when current name, the name of the current name is just blank, essentially. So I could do this. Well, strchr, no, strchr, strlen. If the length of my string is nothing, so it's quote, quote, it's still a string. I'm still storing something in there, but it's not this big, long, verbose thing. Okay, so if the string name length is this, okay. So we haven't stored anything in this big old character array yet. Just fully admit, we haven't done that yet. All I'm doing is getting a character name for each one of these things. And I'm going to return 0 just because I want to test my code first. I don't want to do anything else. I just want to test it and compile. I will go back to it. Okay, this thing I'm also going to pass in an array of character pointers and the maximum number. So let's do this. Let's comment this stuff out. I don't want to be putting in that point information each and every time when I test my code. Okay, so what's the name of this function? Get names. All right. I'm going to use a static array. Why? Because I know I'm not going to use it again outside of main. So an array names. You can call it different things if you want. So test names, sure. All right, and the size of this thing is going to be 20, let's say. Well, let's do make it 30, just to be on the safe side. That's just see. It's going to be 30. I'm going to make this call, and the array I'm passing in, it is just an array of pointers. Those pointers are then going to point to other arrays. It's pointing to a pointer, right? It's like a scavenger hunt in this case. That's how we do arrays of text normally. So this is just an array of character pointers. Each of those character pointers point to another array. It effectively becomes a two-dimensional array. So I'm gonna show you what this thing's gonna look like. It's gonna be some bunch. David, and it's gonna be Andrew. Embarrass all of you guys. Jeanette. Jenny. I'm gonna get everyone's name in there. Who else am I missing? Am I missing people? Probably. They're probably all about to abandon ship. No, no. Oh, that's all you guys. Too bad. All right. So this is what it's an array with arrays inside of it. This is an array that I point to this array. And I'm pointing to this array. And then I'm pointing to, in fact, it'll be something like that. This is just a pointer to a piece of text. I'm just gonna leave it like that. Okay, I'm gonna get the names from the user. So let's see what this thing looks like. Let's see if we actually can stop our function. And then let's move on after that. Enter a name. So David. All right, Andrew. Yeah. I'm gonna stop there and see if it actually stop. Let's put a breakpoint. I don't know what's going on here. Should put a breakpoint in here. Oh, it's not, if I just put an enter, it doesn't do anything at all. It doesn't, what the heck happens? Let's try it again. Oh, continue. All right. I'm going to make a brand new name. I'm going to get the input from the user. Why isn't it stopping there? I'm going to change that up just for our own sake and our own sanity here, because this scanf is looking, it should be putting something into current name. It doesn't seem to even be going to the next line until you put in something. So I could put in a space. And that should have done it. Oh, I hate scanf. All right, let's change this around a little bit. See, that's why I tested that beforehand. Enter dash dash one complete. Okay, I'm going to have to compare two strings. So strcmp. I'm going to compare the current name to dash dash. If I put my quotes in the right place, that's what I'm looking for. And if that's equal a while does not equal 0. So what does strcmp mean? It is testing to see if this thing is exactly character by character equal to this thing right here. If they are, it's equal to 0. If this comes first in the alphabet, it'll be -1, or yeah, it should be -1. If this comes first in the alphabet, it'll be +1. It's a way of testing to see if something is before or after. If I need to sort things, if I need to figure out what order words go into in alphabetical order, for example, that's what that's for. That's why it's so weird looking. So we just need to say, like, if it's equal to 0, they're exactly the same. Okay, let's turn off this, and this, and this. Hopefully we'll have it work. All right, so David, Andrew. All right, and I stopped when I got to this point and I bailed out. Great. So what I need to do now is figure out how to deal with this sort of thing here. So what I might want to do is keep this strcmp thing around. That's going to look ugly, but eh. Uh, gonna look a bit weird, but hopefully this will make sense. So it's equal to 0. All right. So what am I doing here? Or I could just keep this around. So if this is true, I technically don't need this part, but I'm going to do it anyways. If new name, if the name I put in is equal to this thing, then it's not equal to 0, and therefore new name is equal to true. If it is equal to this thing, then it's equal to 0, which means this entire statement is false, which means new name is equal to 0. And so instead of all of this stuff, I'm going to say while new name. And I'm going to put the new name up here just to be on the safe side. Is equal to 1. True, false, they're all end up being the same thing in the end. So we don't have a Boolean in C technically. We have it in C++. So instead we use numbers, but it's 0 and not 0. This is essentially what we have. Okay, so here is do I have a new name? When I did this thing, am I on a new name? If I am, while new name is true, keep getting new names. And I'm going to need a count here, how many names I've entered. And num names is less than. And I want to say, like, yeah, by the way, and you didn't go outside of the size of this array. I'm not allowed to have more than max number of names. So if I get over that, yell at me. Okay. If new name, I can say, I'm going to put this in my array. At position num names, it's equal to, I'm going to pass this pointer in here. So her name. Okay. So if it's a legitimate name, that's what we're doing. This array just has a bunch of pointers. This is a pointer. I just put that pointer in there. And that should be done. And then I'm going to return num names. How many names I've gotten at the end of the day. Okay, David, I'm going to move this over. Andrew, Janet, Sarah. Danny left us. Danny left us. That's weird. That should have stopped it. All right. So this name here, current name is equal to dash dash. It should be equal to this. New name should be equal to, oh, new names. There you go. That's the problem. If you ever wondered about scope, here's a variable called new name. Here's another variable, a different variable named new name. I say int new name. So I have two different variables, both named new name. And when I get down here, this new name has disappeared. This one stays. And so I got an infinite loop on this thing. I got to stop this. Okay. I don't want this. I want that, right? I already have a variable. I'm just going to keep reusing that variable. David. There we go. Hold on. And I think my wife is calling out to me, even though she knows I'm giving a talk for some reason. All right. Continue, and let's see what we have. Andrew. Net. Dash. All right. That worked now. This means I made a whole bunch of different character arrays. I shoved them all into an array that had a whole bunch of pointers to a whole bunch of character array pointers, or character pointers. So I have an array of character pointers. Each one of those points to a character array. Let's print those out. Because what's the point in all of this if we can't do that? All right. Get names. I'm not going to do anything at all. Print names. My names, and this is not the maximum number of names, just num names. The number of names I'm going to be returning. Notice this thing up here, I want to actually catch this thing. So let's go down to where I use this, and I want to have in I'm now going to call print names. All right, I'm going to print off all the names. So what do I need to do? I'm going to go through each element in my array, the outside array, if you will, find the character array. Probably should see if the other ones are null, by the way, in my character array, but that's fine. I could do that actually. So for int I is equal to num names, I is less than names, I plus plus. I could clean up all the rest of the num names just in case something weird happens. That's what that does. I like being current. So let's print up our this array. So for and I is equal to 0, I is less than num names, I plus plus, printf, say name is I and AA names at position I. What is this? That is a pointer to, this is my character array, right? It's pointing to my character array. It is just an array. It's just a C string like every other time. It's pointing to a chunk of memory that has a whole bunch of characters in a row. I don't need to do anything besides this. It's just a character array that I have. And this should print off all the characters in the array when I'm done. And let's try that. Every time on the wrong screen. There we go. David, Andrew, Sarah, Jeanette, Shash, Andrew, David, Andrew, Sarah, Jeanette. Great. And it printed off all the different names that I wanted it to print off. Okay, one more thing. I got a character array. I got to clean this stuff up. So these static arrays, don't have to do anything about them. But every dynamic array, every time I call malloc, I got to call free. So void free names. I'm going to use the same darn thing as last time. Then the extra parentheses. All right, I'm going to do the same thing as I did last time. Lazy. I feel lazy. All right, free up that individual array. I want to actually, what maybe I want to say is this: if AA names at position I not equal null, free it. And when I'm done, AA names at position I, set it to null. To make sure I've freed up all of this dynamic array. Every time I call malloc, I'm calling free. Every time I call malloc up here, I call free, except there's one little problem in this case. Anyone spot the potential issue that I'm not sure what the workaround is for? Oh, I think I have a workaround. I have a workaround. Yeah, I have a workaround. It's right here. It's the only workaround I can think of at least right now. If I get a new array, call malloc here, I need to free it, even if it is a dash dash. But that dash dash isn't being recorded anywhere. It's just being thrown away. I need to free it up. So I actually would need to free her name. So if, in fact, I don't have a new name, if it's actually dash dash, I don't have a new name, I want to free that current name because I know for darn sure I'm not going to be using this thing. That's a weird little gotcha in there that I wouldn't put on an exam, but something I just noticed. Okay, so I go through, get a whole bunch of names. I fill in the rest of my array with nulls just to make sure that there's nothing there. I don't get default safe values in C, unfortunately. I then print off all my names. I just have a for loop, just print off all the names. And then I'm going to free up the names at the end. And I don't need to do the outside array because it is static. If it was dynamic, I would need to do it, but it's static. We can make it dynamic if you want. If you want to see that in action, I'm more than happy to do so. And then renames. But since it's static, I don't need to touch it. If it's dynamic, I need to clear up all the inside arrays, the arrays inside the bigger array, and then free out the outside one. Because otherwise, if I free out the outside one, I lose all references, all like, yeah, all pointers, all the inside array pointers, right? If I clear all those things out, I have not, they're still mine. So, oh, we did Easter egg hunts for Easter with my boys. If you have one of those scavenger hunts where you have to go from this to this to this to this to this, if you throw away the original note in the scavenger hunt, what happens? And we didn't do this, but we always lose an egg or two every single year. If you have a scavenger hunt one after the other, and you miss the first one or lose one of them, someone steals a scavenger hunt clue at the midway point, what happens? You don't go to the rest. More importantly, when you're trying to clean up the scavenger hunt, even the person that made the scavenger hunt may not know where the rest of the stuff is. And you're in trouble because you've lost something. You need to go to the end and then, and then trace back your steps, or follow the scavenger hunt, go to the end, then remove that item, then go back one and back one and back all the way to the front. So this, hopefully, all right, let's run this and see what happens here. David, Andrew, Jeanette, there. Dash. Dash is a very nice student. Okay, I have all their names. We printed them all off. The free and all the arrays were freed at the end. No problems whatsoever. And I don't have any wasted memory. That was a long walk covering a whole lot of different topics. I'm hoping that made sense, Sarah. I know that was probably more than what you were expecting to hit, but this is an array with arrays dealing with pointers of pointers in this case, because each of those character arrays is that. Great. Other questions? You guys want macros? I was expecting one of my other students to show up talking about macros because he gave me this late one night this week. This thing. So macro one, this is what this is. And he had a bug somewhere in his code. In fact, here was the bug. Honest to God, that was the bug that you could spend hours looking at. Those macros, unlike everything else we do, they're not checked with a syntax check or anything like that. It just says, okay, when you see the word macro one, put in val1, val2, val1 times val2. You have no idea what val1 is. You have no idea what val2 is. They're just random things, and everything blows up as a result. Literally, that space made all the difference in the world. This now says, if I see macro one, this call to macro one, I will make you will take the next two numbers immediately afterwards that are in parentheses, and everywhere you see val1, you'll put in that number or that whatever it was. And everywhere you see val2, you'll put in that whatever it was. So let's see an example of this. There we go. I think this is macro 2. Macro 2 is val1, which is value 5, value, and then value 3. It will put in a 5, it will put in a 3 here, the values there. Or actually, it will just replace the variables, but I could put in a 5 and a 3 here, and it would be perfectly fine. And it's going to, this whole thing will be exactly equal to val1 times val2. It's like find and replace, rip that thing up, plug in 5 times val1 times val2. It doesn't call a function. It is a find and replace, essentially. And all the weird wacky quirkiness. This is defining this thing as everywhere you see this. And so we could call it V1, V2, and that would be perfectly fine. V1, V2. It doesn't have to be called val1 and val2. V1, V2. Everywhere I have V1 and V2, I'm going to put val1 and val2, find and replace, hot swap it, and we're good to go. Or better yet, let's do it this way. Answer 4, 5. Everywhere I see val V1, I put 5. Everywhere I see V2, I put 3. I get 5 times 3, 15, which is exactly 15. So answer 4 is 15. I'm not actually calling any functions or anything like that. It is pre-computed as 15. That's what answer 4 is. It doesn't actually get executed at all. In fact, let's put a breakpoint on it. Answer 4 is going to be equal to 15, and that's it. This macro 2 that's down here. That's must be macro 1. Have a look. Macro 1. All right, let's do that. Macro. So my numbers are off. Macro 1. All right. So this thing, answer 4, should be equal to 15 the moment I get to that line. I can't go into the function. I can't do anything like that. I will just go to that line. So dash dash, hopefully that's going to work. All right, I'm now on, in case you're wondering what I was doing, I'm now on macro 2. Answer 4 is not anything at all. I'm going to walk into the function. Oh, wait, I can't walk into the function. Can't do anything. Oh, that's full screen. Okay, how do I get out of this? I'm going to have to stop my entire thing. Hold on. All right. There we go. Answer 4 is equal to 15. It doesn't do anything. It doesn't call a function. I don't walk into the function. It just is 15. It's a hot swap. This is the exact same thing as saying same as 5 times 3. It is a hot swap for 5 times 3. If I go to 5 times, that's down here. There we go. It is 5 times 3. That's what this thing is. This entire thing gets hot swapped in for 5 times 3. Because V1 is 5, V2 is 3. All right. Can I unpack anything about macros? We just did a 2-dimensional array, technically, with all those names. Anything else you guys want to see? Zelda pipes is a problem. No. I was chatting for an hour and a half right now, so I can see why some of you may be tired, but I also want to make sure that you have any questions you have in your head answered by now. So what kind of things can show up on the exam? Maybe I'll let you answer that. What do you think can show up on the exam? That's actually the point of that lab exercise that we were doing with the make a question for the exam. Because you knowing you thinking about what kind of questions show up on the exam ends up telling you how to study for the exam. It's a studying exercise, essentially. So there's 3 of you. What do you think's on the exam? Pointers, yep. And finding errors in code, yep. Pointers, again. Yeah, but pointers pop up in weird, wonderful ways, like malloc, like any arrays whatsoever. But yeah, pointers will pop up. Accessing pointers will pop up. I'm assuming C strings will pop up. The size of an array. How do you get the size of an array? Binary, probably. Binary hex and conversion to 2's complement. Wait, let's do 2's complement thing, just in case you forget. So what is -3 as a yeah, 4-bit 2's complement number. So what do I do here? 3 is 4 bits. 3 is this. Is 0, 0, 1, 1, right? 3. 2 plus a 1, 3. So if I flip my bits, what do I get? I get 1, 1, 0, 0. Just make ones zeros, zeros ones. I get 1, 1, 0, 1. And that's -3. If I take -3, I know it's a negative number, right? So because it starts with a 1. So flip, get 0, 0, 1, 0. 1. I get 0, 0, 1, 1. Two's complement, yay. That's just the mechanical nature of how you convert them. Effectively, what it's doing is it takes a top half of the numbers, says those are negative, takes the bottom half of the numbers in that range, say those are positives, and then the math just works for you. If you say the midway point is 0, then actually, sorry, not the midway point, that you take the first the lower bunch of numbers and then you just wrap it around. What you end up getting is, let me see here. 7 is going to be 0, 1, 1, 1, 7. Can't do 8 with a 4-bit binary number. So 1, 0, 0, 0 is -8 should be. Let me double check this one. So if I flip all the bits, I get 0, 1, 1, 1, and then add 1, -8. Okay. 1, 0, 0, 1 is -7. 1, 0, 1, 0 is -6. 1, 1, 1, 1 is -1. And when we add one more to it, I get 0, 0, 0, 0, 0, because I add one more, boils over, is 0. It can be, but bit shifts are not as crazy as you might think. So let's try one. So what is a bit shift do for me? What is that? I actually have it up here. Master sword. Has the master sword. What is that thing? I get a 1 and a whole bunch of zeros in the front. And then I shift that 1 over 2 places. So it becomes a whole bunch of zeros, a 1, and then 2 zeros afterwards, which is a bunch of zeros, a 1, and then 2 zeros afterwards. That is 4. Wait, what's 2 to the power of 2? 4. What's 2 to the power of 3? 8. What's 2 to the power of 4? 16, 32, 64. It's actually the power of, if I just take a 1 and then shift it over that many bits, it's 2 to the power of whatever that number of shifts are. More importantly, if I just bit shift over, it's the same as multiplied by 2. Now, if I bit shift the other way, it's the same as divide by 2. It's all it is, it's doing multiplies and divide by 2. So this is, let me see here. Where is this thing? Where was my bit shift thing? All the way up here? Yeah, there you go. This is multiply whatever number it is. So let's say it's, 3. You multiply it by 4. Multiply it by 8. Multiply it by 16. Just shift that many bits over, which means the same as multiply by 2 to the power of 4, 2 to the power of 2, 2 to the power of whatever. That's what those arrows are. I do them a little bit. They're not meant to be the be all and end all, but you should be exposed to them, much like, viruses, I guess, or I don't know, uh, chickenpox back before they had vaccines for chickenpox. Uh, so it's turning the 2 into 2 to the power of whatever the second number is. Yeah, or it shifts it over that many bits. So 3, let's do it 2. What is this? This becomes 0, 0. Okay, let's say that's 3. Is equal to, what do I have? I'm going to shift it over 2 positions. So I'm going to have 2 zeros at the end. So it's going to be 0, 0, 0, 0, 1, 1, 0, 0. Essentially, I moved the bits, every bit over by 1. Moved everyone over by 2 chairs. What's this in the end? Which is equal to 8 plus 4, which is equal to 12. Okay, which is what? That is 3 times 4, isn't it? Isn't that fun? It's almost like computer science and math are related. It's kind of crazy. I can't do math, or at least I keep saying I can't, but 3, not 4. I wrote the 3 over here. Oh, did I? It is 8 plus. Thank you. Thanks. That's the reason I can't do math, by the way. It's the fiddly diddly details that I don't see. Um, so I'm pretty sympathetic for little typos and the like on exams. I'm not okay with people I will get people that will take what my question was, copy the question, plop it down, and hope to get points. And you're like, you used copy and paste. That doesn't count as an answer. You doing something, I give lots of partial credit, but just recopying the question does not count for anything. I've had someone spend the exam retranscribing by hand code that I gave him. So I gave him code to help with one of the questions on an exam, and they just copied the code I gave them as an answer. And I'm like, why would I give you that as a question on an exam, right? We're asking you to think through how you do things. So if you're off by a little bit here, let's say you have a little mistake here and you, instead of doing this, you go this. We're going to give you a whole bunch of partial credit for all the steps you did along the way based off of what you did wrong up earlier. Other questions about macros and all that kind of stuff. We have examples of macros, and this code, by the way, is available to you guys on the shared drive in the sync folder, I do believe. But here's me. This is me trying to not remember, what the value is for a binary number with the 4th bit being on. I don't want to have to remember that. That's the only reason I do this. I want to have some representation of like, yeah, the 4th bit over here. Oh, the 5th bit. I want that to something to indicate the 5th bit. So that's why I do. This is the 5th bit being on. This is the 3rd bit being on, or 0, 1, 2, 3, 4, right? 5th bit being on. And then I can combine them. So this is a bitwise OR. If whatever the number that this number is, whatever this number is, any ones in common or any ones along the way for either of those numbers bubble up to the surface. Bit by bit, if either one of those numbers has a 1 in that position, character by character, or number by number walking down the line, then it's going to be a 1. The use of bit shift is if I need to do division or multiplication of by 2, which is surprisingly common, really quickly, faster than anything else you can do. Number 2, if I want to have the 3rd bit, like in here, I want to have a particular, like the 3rd bit here, or if I want to see if I've gotten all the Ganons, like Windblight Ganon, Fireblight Ganon, Thunderblight Ganon, Waterblight Ganon, I could have a big binary number and just manually or figure it out in advance what those numbers are. But 2 months later, I'm not going to remember what the hell that number was supposed to mean. If I say it's this or this or this or this, I know it's just the combination of these different flags. So I've beaten all the Ganons in the game, then it's a combination of all of those flags, which means this is a number with 4 ones in it. and the rest of them are zeros. Which for once, I don't know. I don't care. It's some flag somewhere. So I'm not relying on my memory for what the number is. I just want to say, like, I got some flag indicating whether I've beaten Windblight Ganon. If I have beaten Windblight Ganon, that flag should be on. What flag? I don't know. I don't care. It's defined somewhere. That's also the reason why we have defines. Essentially, everything about programming, it might seem quirky and archaic, but everything, I can't think of an example right now of that contradicts this, at least. Everything is about being as lazy as humanly possible and making the fewest number of errors later on when you can. The exception, of course, is JavaScript, and that's a piece of garbage language. But most languages, when they build a language, they figure out, how can I be as lazy as possible? And knowing that people are going to make mistakes left, right, and center, can I give them something to help them figure out their mistakes? And one of those things, they used to just hard code in values, and people were like, oh, hell no, I'm not going to remember what that value means 20 years from now, or even 2 months from now. Let's figure out a way to do constants so I don't have to worry about that. Let's figure out ways of doing, setting off individual flags or individual bits in a number. That's why we do that's why all these crazy things are there. So other questions? Whoa, it went even longer than I expected. Sorry about this, everyone. All right, actually, oh, shoot, I have a TA meeting. At least I think I do. I'm going to go to my TA meeting for 2400 and see how many of them are panicking right now. I'm going to, so I do have to leave, but let me stop my sharing. The code here is actually available online for you guys if you want to look at it. And let me know if you have any other questions before the exam. You should have plenty of practice questions found online after Janae posted that thing for the labs. All right. Thanks, everyone.